Ethics and existing systems. The principles and morals that govern someone's behavior is referred to as ethics for that individual. If the set applies to a group or organization, it is called ethical guidelines for them. Ethical principles serve as a guideline to distinguish between wrong and right while making decisions or doing something. For example, I may have freedom to walk with a stick rotating in my hand. No harm. But I shouldn't do it in a crowded road, or more realistic scenario is of a deserted road with occasional traffic, but I still wait behind the driving wheel for the traffic light to turn green, though I could have jumped red light without causing any harm to anyone, or simply when we put our smartphone on vibration in a hospital or movie hall. So, ethics are moral obligations that we must comply with. Artificial intelligence is fast in nature, vast in scale, and impactful on industries and society. So, like anything fast, vast, and powerful, it has potential to cause benefit and harm as well. When AI outcome or predictions will cause benefit, it is good AI, and if harm, then it is unethical AI. AI is being developed by humans to impact humans finally. The developers and service providers of AI bear the responsibility of its negative aspects. It is for them to make ethical considerations related to the capability of AI and its impact on society and environment up to some extent. Existing computer programming and software development systems are already governed by codes and guidelines of ethics. Below is a comparison of traditional programming and AI or machine learning. This will clearly show that existing ethics guidelines are not sufficient for AI due to its vast, dynamic, and complex nature and its possible deep impact on existing systems. Traditional versus AI programming. Traditional programming. AI development. The program is based on finalized algorithm which is fixed for one or more versions of the program. Algorithms are dynamic and designed to learn from the data. Data is required to be processed for desired output. Data is needed for two purposes broadly. One, to train the machine, and two, to analyze. Basic approach is linear, that is input, process, output. Basic approach is cyclic, that is input, train, analyze, predict, train, and so on. Data is mostly structured and well classified. Data is unstructured with several variables needed to train the system. Mostly works with complete data entity such as number, text, or image. Can work with a part of entire data such as a face in a group photograph. Used to develop automation and productivity applications. Targets to add efficiency and intelligence to existing and future systems. Requires training from fundamentals of computing. Does not require prior programming knowledge. Requires good knowledge of programming, database systems, and other related technologies. Forms a vast field of computer science and computer applications. Integrates computer science, data science, statistics, math, research, and business intelligence. Follows development models such as waterfall, spiral, agile, etc. Has potential to impact traditional development models to make them smarter. Deals with a limited size of data. Bulk data is processed in batches. Deals with complex, dynamically changing and growing immense amount of data collectively called big data. The good AI. An ethical AI system must be developed around the ethical guidelines of a society or people it is going to influence. An ethical reference is a must in place while developing intelligent machines and conceiving their relationships with humans. Ethics work on mutual trust. Human-machine interaction must be within the borderline of such ethics, trust, values, and morals. While developing AI-based systems to serve people, consideration must be in practice that it must not compromise the basic ethical boundaries established by society or target group of intended AI users. For example, an NLP-based AI assistant must not listen to every conversation you make unless it is activated by the vague command word. Keeping with ethical guidelines, power of good AI can be harnessed in following ways. Optimum use of the present system. Today we have immense data generated during the course of several decades of computing. We also have computers with huge processing speeds. These are two basic prerequisites for AI. Our systems can be utilized to tap into revealing the opportunities hidden in immense data sets. This was not possible until AI emerged. AI can help us reveal facts and information logged in immense data with super speed and take quick decisions for the growth of industry, society, and economy. The speed and accuracy of predictions, creating data visions, object detection, language processing, etc. can help us achieve a lot which would otherwise take several years. Enhancing human potential. AI will increase human productivity multifold. Trained algorithms function as new tools for humans to achieve which was not possible earlier. Possibilities are many: autonomous system, monitoring and autonomous execution of complex tasks. This frees skilled human mind and hand to create, produce and achieve more. Augmented algorithms add efficiency to the system. Addressing the non-addressable. The problems which required handling of huge data to find a solution are now addressable. Problems related with society, poverty, hunger, education, etc., with economy, inflation, recession, demand-supply gap, etc., and problems related with environment, global warming, pollutions, drought, etc., demand the analysis of huge data sets, which is now possible by training the AI algorithms to show us patterns and trends to make strategies to address these problems more effectively. Enriching human life. Smart homes, schools, hospitals, cities and infrastructure powered by Internet of Things, IoT, and machine learning add value to life, making the places livable, workable and sustainable. AI offers potential to augment the capabilities of humans in fields like healthcare, efficient distribution systems for facilities and services. Working towards equity. Bringing AI and big data together can help explore efficient ways to bridge the gap between the haves and have-nots. AI can help promote and sustain equal treatment of all classes of society by creating innovative means and solutions which were not possible earlier. Easing conflicts and uplifting harmony. Data is the new currency of the world. Countries to know to acquire their data, model it well, and use it with AI ethically will prosper, but no country can prosper alone today. AI has the potential to shape the world economy in such a way that instead of restoring for war and other nefarious means, countries will opt for resolving conflicts, iron out differences, and practice harmony to grow together. Giving back to Mother Earth. AI-powered data handling, predictions and systems can act as a vehicle to bring us to green economy faster. Better societies, sustainable means of living and improved quality of agriculture can help in arresting the ill effects of pollution, global warming, climate change and other issues related with environment abuse. Ethical challenges with AI. Despite promising good influence of AI on humans and environment, the big question is how it must happen. How do we ensure that the new power in our hands would be used really in an ethical way? What are the gray areas which we need to identify and make provisions to handle them carefully to ensure ethical AI? Accountability. Who will be held responsible if AI does not bring desired results or turns out to be harmful in different ways? How the accountability of a learning machine would be set? Can an autonomous vehicle be blamed if it runs over a pedestrian around the corner during an early foggy morning? Who is to blame? Owner of the vehicle, developer of the AI system, manufacturer or the victim? System and policies need to be in place to determine accountability for every possible scenario. Transparency and bias. An AI-powered system with learning algorithm will be able to decide a course of action for a task out of many alternatives. How will it be determined that its choice was ethically right? In a recruitment process, an AI machine shortlisting candidates on the basis of their personality traits will perform the selections judicially, is to be ensured by the developers of the system. Machine will mimic what it will learn from the data given to it. The accuracy, versatility, and richness of that data needs certain data quality checks. A biased AI system can unfairly discriminate or produce discriminatory results, eliminating candidates during job selection who did not have preferable qualifications or skill just because the data used to train it did not have a single case of that preferred qualification or skill. This is another example of bias by AI system. Pre-existing biases. Our current systems already have biases up to some extent which come from our societies over several years. For example, if police had not registered complaints of a particular segment of society and this dataset trains an AI system, then it will tend to give lower priority index to such cases as they appeared very less in number in past, while actually they should be treated with equality. Technical biases. Such biases may creep into the system consciously or unconsciously by the flaw of logic. A reservation system may tend to slow down due to higher number of requests from a particular region, thereby making everyone wait longer than usual to book a seat, or an AI system failing to recognize the desired object in an image and rejecting it just because data set used to train it had no sufficient details for that kind of object. Emergent biases. These biases occur when system comes in use. For example, a user interface system for fixing doctor's appointment is too difficult to use by physically challenged persons or senior citizens. Another example could be a learning system that does not allow student to move to next level until previous module is completed successfully, thereby discouraging an average student. Better and efficient testing system need to be introduced in the design and development life cycle to detect and filter biases. Diverse and huge data sets with variably rich values should be prepared to train AI systems. The data acquiring and modeling process need to have sufficient quality checks, security and privacy. Will it be difficult in future to predict up to what extent an AI system would learn and become a threat instead of utility? Think of an AI system that could devise ways to hack into user accounts after getting trained with the rich data sets. Possibilities are there. AI integrated with IoT needs care as it is deployed for domestic and public security. Possibilities of false alarms, auto-locking due to logic malfunction, blockage of access to a vital service, example ambulance due to machine flaw are very much there. Issues related with cybersecurity, cyberbullying and data theft need to be addressed with different perspectives. Compromise with individually privacy in the name of data acquisition, surveillance and a check on right to liberty, data protection breach and copyright breach are certain issues which need to be ethically balanced while developing AI systems. For example, how an AI system be assessed for plagiarism, which generates articles and writes books after reading thousands of similar articles and books? Decision-making, common sense and human values. Harms caused due to unjust decisions, uncalled for actions, and lack of decision-making capability in a learning machine may create more problems than the solution it provides. How can we be sure that an AI system showing trends that help government devise upliftment policy for drought-prone areas is efficient enough to reflect all possible angles in the data view? Another example is of a sinking ship, whereon AI system locks a door preventing water to flood the rooms while the other system tends to open the same doors due to rising smoke. How AI systems will imitate common sense and take care of human dignity and values. Ethical framework for AI development. Forums such as AI for People and organizations such as Institute of Electrical and Electronics Engineers IEEE, which are dedicated to technical advancement with social benefits, have already been working on AI ethics. An ethically aligned design for AI addresses following principles. Human rights. AI systems should respect, promote and protect human rights. Well-being. AI developers should be responsible to keep human well-being in central focus for a successful AI system. Rights related to data. People should have rights and means to control and share their data. Right to individual identity of anyone should not be breached. Effectiveness. AI system should be robust and not prone to hacks and crashes. Transparency. The working and data processing functionalities of AI systems should be discoverable and investigable as and when required. Accountability. AI systems should have a base of rational guidelines governing its working and decision making. Awareness of misuse. Provisions must be there to prevent AI system from misuse. Competence. The AI developers should possess right and sufficient knowledge and skills required to develop intended AI system. The above principles have been collected from standards.ieee.org. https://standards.ieee.org/standards/web/documents/other/ead1e.pdf?mark utm equal to undefined and utm_source equal to undefined and utm_campaign equal to undefined and utm_content equal to undefined and utm_term equal to undefined. Policy framework for good AI. Governments world over are working in devising effective AI policies that govern the AI revolution in their countries in order to ensure benefits and minimize risks to society, economy, and environment. A possible policy framework outline is given here. 1. Existing human rights policies need revision and any new policies need inclusion of ways to protect privacy, dignity, and freedom of people and to check that these human rights principles are not compromised. This will ensure trust among people for the emerging AI technologies. 2. AI should target growth of gross domestic product (GDP) as one of its development principles, since it is directly related to the overall growth of people and nation. 3. Detailed policies and means are needed to develop that ensures that people have access to their data and that their privacy is not compromised. Their data is secured and they are able to share and own their data autonomously. 4. Benchmarks and testing systems should be devised to ensure the effectiveness of the AI systems in terms of performance, robustness, security, data quality, human resource deployment of systems, and their future upgrades. 5. The AI systems should be transparent so that they could be easily tested, measured for performance, and investigated for diagnosing and fixing faults and to investigate data sets. 6. Laws to ensure responsibility, liability of, and for the AI systems, especially when a system malfunctions, breaches human rights, or causes more harm than the intended benefits. 7. New guidelines to be created to decide who should be the stakeholders in an AI system and its ecosystem. 8. AI system developers should ensure that chances of system misuse are minimized or completely checked. Ensure that users are aware of its misuse, consequences, and issues and are able to use the system safely. 9. Policies and guidelines for developers to specify who should be able to use the system or how the system should be used. Also, how to incorporate safety features to ensure that system does not crash, malfunctions, or goes down if someone uses it incompetently. The economics of AI. AI will be used both in enhancing existing systems and to build new systems from scratch. The economics of AI involves two broad questions to be answered. 1. What value will it add or benefit will it bring to all stakeholders? 2. What will be the expenses for intended value addition? AI is no cheaper proposition. It needs high level of expertise in every phase of development. Sophisticated tools and software, state-of-the-art hardware and other infrastructure, immense amount of data for machine training, training of personnel, costs involved in system development and project management. If the sum of all value additions and revenues seems to exceed remarkably the sum of all the above expenses, then AI alternative is worth giving a try. Generally, AI cannot be taken up like the development of a customized software application for any business or general software applications for industries. AI products are available in the form of an entire ecosystem comprising of various hardware and software technologies from which customers can be helped to pick their business solution. Organizations like Google, Amazon, Microsoft, etc. have developed a diverse general ecosystems for AI available in the form of cloud computing. Depending on the client company's requirements, the tools, equipment and storage services are customized. Consultation and support services are provided for the deployment of the system, and project management approach is followed to integrate the AI system with company's existing system, collect and model data for machine learning and train the human resource and customers if required to be able to work with AI system. The costs are involved at customization level considering the requirements of the client company. The benefit of this approach is that the cost for standard development of AI system is saved. Most expenses occur in integration of existing AI technology with client's system. The core technology remains unchanged. By the help of software interfaces, programming interfaces and other integration techniques, AI is introduced in the existing system. For example, to use a chatbot, a bank does not change the way it functions or replaces any major software components already in use. This saves a lot of cost. Another example of economical AI implementation is NLP-based assistant, Alexa, Siri, etc. They can be easily integrated with existing customer support services. The basic algorithms of language processing remain the same. They are just being reused. AI solutions are basically reusable components